Set up. If I mute. Screen up. All right. Sorry, everyone. This is taking me a long time.
One day, quite a bit.
To log in, so many things. Okay, now dash. Now Canvas is up. Prospect theory. That's what I want to talk about. Okay, everyone. Hey, thanks for coming. Today, I wanted to say, not this class, but on Thursday, let's have our third quiz. It's been pretty regular every 2 weeks. We had one at the end of week 2, end of week 4. So at the end of week 6. So makes sense to have a quiz. It's actually our last quiz before the midterm, which is the end of week 7, which is, I think, in 2 weeks, right? Wait, in week 7 or end of week 8? Let me. Yeah. I mean, it's so I'll write on the board just to be clear. Midterm exam will be March 3rd. Right. Yeah, that's the last day before spring break. We have spring break after that. Spring break is next week. It's like March, something like 6th to 13th, something like that. So we don't have class on spring break, but we do have a midterm exam on that Thursday before it. And so we have, well, what? Today, Thursday, and then next Tuesday, just 3 more classes, 3 more lectures before we'll have our midterm exam on Thursday. And of course, it's comprehensive. It'll be over everything that we've done so far. But quiz 3 is not comprehensive. It'll just be over these 2 things. Consumer choice anomalies, there's a module on Canvas that talks about that. I would say there's maybe 4 things in that module. You can go look those up, but it's like, decoy effect, mental accounting, that sort of thing. Arbitrary coherence. One other one? I don't know if there's a 4th, possibly. And then prospect theory, which covers a lot. Actually, prospect theory is a big chunk of this class, because you also kind of have to know how it relates to expected utility theory. To really be able to talk about prospect theory and what it is and why we have it, you need to sort of know how it compares and contrasts to expected utility theory. So I want you to know the basics about expected utility theory so that this makes a little more sense. Why we had this change. This is from the 1940s. This is from the 1970s. Why that change was necessary? And specifically, what is it? We'll talk today. We'll get you caught up on prospect theory today if you missed class last time. In fact, we can start right now. Why not? I wanted to say a little bit more about this paradox called the Allais paradox. We've talked about it before. And let's say you're like a contestant on a show. This is you. And then there's like 4 other people. You're contestant 1, 2, 3, and 4. This is like Jeopardy, but with 4 people instead of 3. And you're playing this others. Here are the 3 others. You're playing this like game show, and if you win the game show, you accumulate these points over the course of the show. If you win the show, you get to play a bonus round. And in this bonus round, your prizes are, it's basically like, spinning a dial to get a prize. And so if you win the show, you get to choose basically the 2 things I asked you to choose from last time, which was, I'll write it this way, $3,000 for certain, or do we do probability first? Okay. Probability then amount, or amount then probability. I think the rule is probability then amount. What do you guys think? How do Kahneman and Tversky write it? Do they write the probability first, or do they write the number first? Okay, they write the number first, then the probability. I'll do that. So you choose between these things. Either guaranteed 3,000 or a 80% chance of 4,000. Right? So let's now look at somebody who has won the game. They did the half-hour game show contest. At the end of it, they get to this point, and they have to decide which of these two prizes do they want. This is prize A or prize B. What do most people choose? A or B? Do you remember? We're talking A. A is more common. Okay, that's fine. People have reasons why they might want A or B. It doesn't really say anything that informative or spectacular that A is more commonly chosen than B. Fine. Here's the paradox. What if before you started the game, after the half hour of the game, you get to this bonus prize and you say, which one do you want? You say, I'll choose prize A. What if before the game even started, somebody asked you, if you win this game, which prize would you like to have at that point after winning? What do you think most people would say? Kind of, right? B. It's like saying, if I played, what are my probabilities before the game has started? I don't think I have any participants. Okay, no one's here. Before the game has started, I should think I have a 25%. Let's say this game is really luck-based. There's no skill. You can't tell whether you're more likely to win than anybody else. It's very luck-based. You have a 25% chance of getting this if you choose A, and you have a 25% chance of getting this. That's exactly the same as, so this is if you win, after you win. Before playing, you're basically faced with these choices, 3,000.25 and 4,000.2, right? All I've done is I've taken the probabilities as a 1 implied here, divided them by 4. The reason I've done that is because the chances of you winning the game show are 1 in 4. Then you multiply that by the probabilities, you get these prizes. Here's 1 and here's 0.8. That's where I get these two numbers. Agree? If you ask people between these two things, what do they say most often? They choose this one most often. I think you guys were a little weird. You didn't have a majority flip like most people, but that's okay. It's a paradox because why should you so this is equivalent to like forcing your future self to take option B against your will, isn't it? If you say you want this, D instead of C, that's saying, if I win in the future, I want to force my future self to take option B, not option A. Even though, for most people, if they won, they would prefer option A. So it's a paradox almost in your own mental capacity to decide what's good for yourself. Because before the game show starts, you tell yourself one thing. After you win, you regret your decision and you want to tell yourself something else. And that just doesn't fit with how neoclassical economics thinks about decisions under uncertainty. There shouldn't be any way to like force yourself or trick yourself into doing something that your future self doesn't want to do. That really doesn't make sense in the current, in EUT. Expected utility theory says that should never happen. Prospect theory says, actually, it's perfectly logical. It could happen. But do you see why it's a paradox? Did I write this equivalent to forcing your future self to take a worse option? I didn't finish that. I think I said it in words, but I didn't write it out. Does everyone see how this option D is like forcing your future self to take a worse option, which doesn't make any sense? This is called the LA paradox, by the way. LA with a parenthesis, with an apostrophe, which was already known about in the 1950s. want to get the timing right here. 1940s, we had EUT. 1950s, we have Allee paradox. 1970s, we have prospect theory. Prospect theory was created as a response to Allee and some other people who found these paradoxes within expected utility theory. And there was a demand for something that says, how can we resolve all of these paradoxes with one theory? We don't like to have a different theory for every situation. We'd like to have one general theory for how people make decisions under uncertainty. That's what prospect theory is. So to address this problem, you guys remember what they did? I'll write the initials. They created a probability weighting function. The probability weighting function fixes this paradox. It fixes the paradox. It says, that is not a paradox. Those are two different decisions. The decision you make before the game show and the decision you make after the game show are different. The way your mind conceives of those options is different. And the reason is because you weight the probability is different. If you're thinking about a 20% versus a 25% chance, your brain thinks about that probability in a certain way. If you're thinking about an 80% versus a 100% chance, your brain thinks about that probability in a different way. And it's not so simple that you just multiply by 4 and you get the same answer. Prospect theory says, no, that's inaccurate. What should we have? We should have a function that takes as an input all the numbers between 0 and 1, because all real probabilities are between 0 and 1. This would be the probability axis, P. And on this axis, we should have W, which is the weight of our probability. You can imagine a 45-degree line here. This is the true probability, right? The 45-degree line says for any probability, you just return the real probability, 0.2, 0.2, 0.3, 0.3, 0.4, 0.4. It's a 45-degree line, so it's the same on the y-axis and the x-axis. But here's Kahneman and Tversky's insight. It says, what can explain the Allee paradox is an insensitivity to these numbers. Insensitivity means the way we incorporate that into our decision making is not as sensitive as it should be. Sensitivity is like, how much do you notice changes? I do this with the lights, right? You turn the lights down, you really notice those changes. There's certain changes we really, I'm not going to do it, but obviously I did it before. There's certain changes in our experience as a person that we really notice. We really pay attention to that change. Oh, you got taller. You must be wearing boots with some heels on them. Oh, this drink tastes really sweet. It must not be diet. I asked for Diet Coke, but you gave me regular Coke. How can we tell? We can really notice that. We're really sensitive to those changes. You slapped me too hard. We're just rehearsing for a play, and you're supposed to slap me a little bit. You really slapped me too hard. Okay, sorry. Insensitivity means I'm not really focusing or paying attention to those differences. And the theory says I don't really notice or pay attention to these differences between these two probabilities, not nearly as much as you should. And these two, you really do. How would you draw that on this? What does it mean to be insensitive? Insensitivity to probability changes. If this is the phenomenon that we want to graph, should I make the line steeper than the 45-degree line or flatter than the 45-degree line? What do you guys think? You say flatter? Flatter is correct. It should be flatter. That conveys this idea that we're not as sensitive to probability changes as we should be. What would it look like? Well, a lot of ways to draw it. Oh, by the way, it can't be flat everywhere, can it? If it was always flatter, it would never get to here. But let's say this is 1. Doesn't go any further than 1. Right? This is a special point. 0 and 1. 0 and 1. We should know that probability 0 equals 0, and probability of 1 is 1. So we're not going to fool ourselves into thinking that something that's certain isn't really certain. or something that won't happen really will. That's not what this is about. This isn't about, magical thinking or anything like that. So it has to hit 0 and it has to hit 1. And it should be flat most of the time, right? To capture this. There's another effect that I haven't talked about yet, which is called the certainty effect. And that's another psychological finding that was known for decades, 1950s, 1960s. What is the certainty effect? You certainly, you feel different about something when it's certain than when it's uncertain. That just has to be true. Those are two different experiences. And think about this idea of regret and loss aversion and how it could be that, oh man, I would love to do this, but I don't want to risk something bad happen. If I can do this and I'm be certain that it won't happen, I'll have this peace of mind. Well, this happens in a lot of situations. Even when we're talking about money, that's happening here. If you choose option A, you get some peace of mind, don't you? You know you're going to get the 3,000. You're not putting your outcome in anybody else's hands. This is the idea of the certainty effect is you get some pleasure in knowing that your outcome is certain. Really, that's basically what it says. And it also will affect your probability weights. I should say it may also come with some displeasure if you know the thing is bad. A bad outcome that's certain is particularly bad. A good outcome that's certain is particularly good. That's what I mean by the certainty effect. So this function, the PWF, should have these two aspects in it. How do we draw it? Well, there's many ways to draw it. How about I choose a different color? A different color will help to illustrate this. How about it looks like this? That'll do, won't it? It has this big jump here. That's the certainty effect, right? The big jump says a probability of 0 is very different than a probability of 0.001. Think about lotteries, like the actual super lotteries or the Mega Millions Powerball, that's what it's called. Do you guys think you're actually going to win a Powerball lottery? No. But what if you did? I mean, isn't it just like, maybe it's possible. Does anybody here actually play like the big lottery games, like the really big ones where it's $100 million if you win? Nobody here plays them. You played them sometime?
Yeah.
Do you feel like you might win?
Not really, but
Really?
there's a chance.
But there's something there, right? It's not the same as just like donating money, it's going to be gone, I don't care about it. You do feel something that's perhaps a psychological effect of, but maybe it will happen. I think that is what's being captured here at this point, really close to the origin of 0, 0. Why does it jump up so much here? Because even if you think about playing something like the Powerball lottery, when you buy that ticket, you are thinking that there's some chance that you win. And just sort of measuring that chance that you win is hard to do. There's some uncertainty, like how likely am I actually to win? But because it's so close to 0, it's going to be biased up. The way we feel about that probability, it's going to be higher than the true probability. It's almost guaranteed. And that's why this is really steep here, certainty effect. Okay, but I also think it explains why somebody might want to buy a lottery ticket. Even though it's really unlikely to win, you still feel like maybe you will win. There's some chance. Do I know the chance? No, but it's some chance. And this is like, that's like this range. This range here is like the some chance in your brain. It's vague, but it's there. What about all this range here? That's the insensitivity to prob changes. I'm really abbreviating here. The fact that this part here is really flat, that's the insensitivity to probability changes. So if you look at, I'm going to try to draw 0.2 and 0.25 and go up here. Where do these 2 points meet on the red curve? at a place where it's pretty flat. And that means before the game show has happened, you're thinking about this event that may or may not happen in the future and that you may or may not win this money. Those probabilities are small enough and you become as insensitive to the probability changes, insensitive to the probability changes that you're likely to just pick this one because it's more money. It's more salient to you. The word salient is like, how present is it in your brain when you're thinking about something salient? And that explains it. Whereas after you won, this is no longer hypothetical. You're no longer thinking about these distant probabilities and what they may or may not be. You know exactly it's 0.8 versus 0.1. I'll do 0.8 on here too. And look how big that difference is. That's a huge difference. And that's why you might choose option A here after the game, option D, right? It's a way to sort of explain the Ale paradox. Have I convinced you of that? Have I convinced you that the probability weighting functions of prospect theory, by the way, this is part of prospect theory. Maybe I didn't say that. Prospect theory has many parts, but the first part that I'm explaining to you is this function in red, called the probability weighting function. And what you would need to know about the probability weighting function is that it captures those two effects. The first one, the insensitivity to probability changes. The second one, the certainty effect. And remember, the certainty effect happens at a probability of 0 and 1. So something that will certainly happen or something that will certainly not happen. Both of those are called the certainty effect. It doesn't have to just be at 1. Good. Yeah, so now you guys know the probability weighting function. Now I want to talk about the other major part of prospect theory. But before I do that, I think let's play a little game. I feel like the guy from Saw. Let's play a game. I want to see what you guys will do. And I'm going to ask you some questions that are about people dying. It's about death. So it's really like this guy from Saw.
Definitely uplifting.
Very uplifting. It's like a virus that's killing people, a pandemic. It's terrible. What?
That's COVID.
I mean, listen, I didn't write this question, but I took it from somewhere where it's like, yeah, especially relevant now when you're thinking about, what am I doing? I went to dashboard. I meant to go to MobLab. So I would like to play a MobLab game now. Well, once again, you're not playing with each other. This is just a survey. I'd love for you to answer it honestly about yourself. Don't try to like figure out what I'm getting at here. Just try to answer it honestly. But yeah, trigger warning, I guess it is about a disease where some people may die. If you don't want to play, I don't want you to have to play if you don't want to. In my defense, I did not come up with this. This is something that researchers in my field have created as a tool for asking these sorts of questions. Yeah, so you're gonna ask you like you're a policymaker, and which of these two policies do you prefer? And that's really what it's coming down to. And just answer honestly. See if you can. It's hypothetical too. I'm not going to actually choose any policies that affect your life or the lives of real people. It should be up now. If you go to my classroom, behavioral economics on MobLab, I see 10 of you have logged on. That's good. There should be multiple questions. Should be like 2 questions for you to answer. One's just about money, so that would be it. One's about people dying, whatever. Oh yeah,
I've seen this question before.
oh, really? Yeah. Have you read about it in an article that I've assigned? Huh?
No.
Oh,
I mean,
in a
like
different class?
freshman, like psychology 101. I
Oh,
think they
yeah.
asked this.
Yeah. I have to say, I'm borrowing very heavily from psychology in this class, especially the first half of the semester. It's like, mostly psychology. Really. Uh-oh. There seems to be an error in retrieving modules. What does that even mean? Yeah, it's on my end too. It says 21 groups have started, or 21 people have started, and 10 people have finished. So it sounds like, I think you guys are mostly getting in. There's only 25 people in the whole class, so almost everybody in the class has done it. That's pretty good. Actually, I think there's only 24 people in the class. Now 22. 22 out of 24 people have done it. Wow.
What is C&D?
What?
Isn't the option?
What?
C&D for question.
Oh, that's my fault. Ignore C and D.
Just one or A and B.
Yeah, yeah, sorry. That was, oops. C and D should not have been there. It's sort of the default for multiple choice question. It gives you 4 options. I forgot to delete them, I suppose. If you do choose them, that shows me that you weren't paying attention. Because the option C or D does not make any sense. Here's a class section. Oh, it's mirrored, and then it's mirrored again. This is me mirrored, and this is me unmirrored because it's twice mirrored. Interesting. Oh, you guys are done. Great.
You're looking at yourself on camera.
Yeah, I am. No, there's me. I'm that way. Yeah, let's look at the results. Here you go. This was the thing. Here are the results. Oh, by the way, let me explain what I asked you and why. It was about a disease, and you had to choose a policy where different numbers of people might die. However, it was framed in 2 different ways. So this was actually a question about framing. You didn't realize it. Hopefully you didn't realize it, but it's a question about framing. Even though you had exactly the same outcomes, some people I asked about how many people will die. And the other half, I said, how many people will be saved? So the framing there is what I would call either in the domain of gains or the domain of losses. And psychologically, I'm talking about now. Really, both cases are terrible because there's some people dying from a disease. But whether it's framed as something where you can have some outcome in the domain of gains, that would be the one about people being saved. And then another outcome where it's all in the domain of losses, where those are the ones with people dying. So once again, going back to like, why does prospect theory exist? There was a well-known psychological effect that predates prospect theory, just like Allais paradox predates it, that said, if you frame something with uncertainty, there has to be uncertainty, in the domain of gains, people tend to be risk averse. I talked about risk aversion. I hope you remember what that means. It means I would always prefer the expected value outcome as opposed to the uncertain risky outcome. That's risk aversion. But the theory says that you only do that in the domain of gains. In the domain of losses, you actually become risk seeking. You actually want to take risks in the domain of losses, even though the outcomes are exactly the same. Let me show you that the outcomes are the same. Let's look at the choices, right? This was the, can you see that? This was the choices of 200 people will be saved for sure versus 1/3 chance 600 people will be saved, 2/3 chance 0 people saved. This is the domain of gains. I'm talking about how many people's lives can you save. Saving a life is a good thing. This is the risky option. This is the safe option. So the psychological effect, actually, I'll give you the name of this effect. It's called the reflection effect. Reflection effect. Should I write that on the board? I've given you these 2 effects. Here's a new one. Reflection. The reflection effect says, I can take this uncertain option and reflect it in the frame, in the way that it's framed, so that everything that was framed as a gain is now framed as less of a loss. Everything that's, a big gain is actually less of a loss, and a small gain is actually more of a loss. You can always change that basically by changing the reference point. If you think about it, the reference point is how many people are going to die. If your reference point is 600 people are going to die, but some of them might could be saved, that's the domain of gains. But you can reflect that and saying, my reference point is 0 people die. How many actually are going to die? Those are all the domain of losses. So it's called the reflection effect because of this fact that you can reflect anything that's a gain, you could call it a loss just by changing the reference point. Do you agree with that? If I said, here's $5, that sounds like a gain, right? Oh, you just got $5. Well, no, what if I said, okay, here's $10. Oh, wait a second, I said, okay, now give me $5. That's now a loss. I've made you pay me $5, even though the total difference is the same. I've given you $5. Okay, so what does the theory predict? Theory predicts more people are going to choose, why can't we see this whole thing? We'll choose the safe option in the domain of gains. Exactly what happened. Good. You guys are normal human beings. I like that. Most people chose the safe option when this question is framed in the domain of gains. Good. Now let's see what happens in the domain of losses. That's this question. Oh, it's perfect. You guys are real human beings with real psychology that I can talk about, and it makes sense. When it was framed as losses, almost everybody took the chance. They took the risk-seeking chance. Even though, if you think about these two options, they're exactly the same in terms of the number of people who will die. You might say, wait, one said 200, the other said 400. Do you want me to draw a little thing here that'll show you how it's the same? I think I can do that. Probably most of you see it already, but let me just make sure. Make sure it's clear. Because the numbers should switch from 400 to 200, but they have to switch. That's part of it. If this is like how many people are living and how many people are dying, but it's just number of people. If we say we start here with 0, let's do number of deaths. This is number of deaths. And this is 600. This is deaths. If I say one policy saves 200 people, that's this distance here from 400. This is 200 saved, or it's actually going backwards, or 1/3 chance 600 saved. Right? Your choices are 200 saved or 1/3 chance 600 saved. Most people chose 200 saved, right? Versus if you started, that's starting from 600 deaths. If you start at 0 deaths, you're talking about 400 die. Wait, is that right?
Yeah.
Did I ask you?
Yeah.
400 die, or 2/3. Is it 2/3? 2/3 chance 600 die. What I would argue is that the 200 saved and the 400 will die are exactly the same. You both end up at this point. And then I would argue that the 1/3 chance of 600 saved means I'm 1/3 probability of being here, 2/3 probability of being here. That's exactly the same as a 2/3 chance 600 will die, because once again, it's a 2/3 chance on being here, 1/3 chance on being there. So the two questions I asked the two halves of the class are exactly the same in terms of the outcome, in terms of where you are. Your choices are, do you want to be here with certainty or here with probability? 2/3, no, 1/3, sorry. 1/3 and here with probability 2/3. The only difference is the framing of this, right? Whether it's framed as people dying or people being saved. So this is a very powerful effect. You can also call this a framing effect. I've called it the reflection effect because it should work anytime you reflect something that is a gain in terms of a loss. But in general, these are called framing effects too. a framing effect could happen even if it's not a reflection. This happens to be a reflection where gains or losses, losses or gains, and they flip them. But there are, in general, there are other types of framing effects that say, anytime I change the reference point in your mind, like the starting point, the status quo, I change that in your mind, it may have some effect of how you interpret gains and losses that affects your decision-making, especially under uncertainty. So this is a little bit more general, calling something a framing effect. And a reflection effect is the specific one where we reflect gains and losses. But it happened. I'm glad. Last time it didn't work out so well, so this time it did. Actually, does anybody have another explanation for why this is? Let's go back to the, why did so many people choose the risky option when you're talking about people dying, and they chose the safe option when you're talking about people being saved? Why? Is that an answer? I mean, I gave you this answer in terms of, I don't think I gave you the answer of why it happens. All I said was, is that it happens. And I gave it a name. But do you guys have an answer for why? I'm curious. Most people choose to take the safe option when you're saving people, and they take the risky option when people are dying. Why? Nobody has a thought. I mean, there's no right or wrong answer. I'm just curious. Yes.
I think when you start off with the word save, you think, okay, that's my job. That's what I have to do here.
Okay. So there's something about the word save.
I think I'm, whereas if it's dying, it's like, oh, this is bad. I've got to get out of this somehow.
But in both cases, though, I mean, I agree with you that I would say what you're talking about are semantics, which is like, what is the meaning behind this word and how do I interpret that meaning? And I would say, yeah, you're probably right. There's definitely some semantics going on there. But I also think there is something that the way that we feel about losing something, about something bad happening versus about something good happening, and the risk that we're willing to take in each of those situations. But that's what you were saying too. Good. Okay, I think we agree. I thought you were saying just the word save sort of triggers something in your mind that I have to guarantee that I'm saving at least one person. Like that's my job. I have to save somebody. Whereas if it's talking about people dying, you don't feel that trigger, and maybe you just say, let's try to have no one die, right? Of course, for no one to die from this disease, you have to pick this one. I think, but most people don't. Okay, good. I mean, I more or less agree with you. But I also think the framing is powerful, and the reference point is powerful. How we feel about gains and loss. We already know about loss aversion, don't we? We could talk about that too. But remember, the loss aversion, that was like, do I want to make a bet where I could either win or lose versus just playing it safe? And then we saw, okay, people usually just want to play it safe. How does that apply here? Do you have a comment?
Yeah, I feel like loss aversion applies more to the death one, and this is more like status quo bias, because like you see the number that you're going to lose, and then you're like, oh wait, I can lose less. But then in this one, you're like, well, if I'm already going to save 200 people, I might mess it up and save nobody.
Good. So you're saying loss aversion is kicking in, not for this question, but for the other question.
Mm-hmm.
And it doesn't kick in. That's exactly what the psychologists would say, what Kahneman and Tversky would say. If there's something special about losses, it makes us feel particularly bad about losing. And remember, this wasn't like the Derek coin flip that said, do you want to risk a loss or not? Because in either way, there's going to be a loss with some probability. So what Kahneman and Tversky sort of had this insight that says, we can do something that captures all three of these things at once, because they're somehow related. You can't look at them in isolation that says, well, sometimes we have loss aversion, sometimes we have a framing effect, sometimes we have a reflection effect. No, it should be all three in one. And in fact, they did come up with it. I wouldn't be teaching you this unless they did have it. But before we go on, I'm wondering if the same thing happened with dollars. I did the same thing where I framed something as a gain or a loss, even though the outcomes were the same but just in dollars. And I'm wondering if it didn't have as strong of an effect. Let's look at it. So here is the options were losing 500 or winning 500 were the safe options. So the prediction is more people would take the safe option. I should write this down so everyone can see it. It's on my slides, but I don't have my slides up. Somewhere where everyone can see it is in the domain of gains, you choose the safe option. In the domain of losses, you choose the risky option. That's the prediction, which is more or less summarized in this reflection. In the domain of gains, if I'm talking about gains, like do you want to take a risk over gains, you're more likely to choose the safe option. And if I say, do you want to take a risk over losses, you're more likely to take the risky option. So the prediction is when you're losing 500, you should take the risky option versus when you're winning 500, you should take the safe option. Let's see if that happened. Losing 500, pretty close, but nope, people didn't take the risky option. Never mind. Okay, how about, so it almost doesn't matter what happens here. Oh, you guys were backwards. Okay, winning option. You were actually more risky for the gains than you were for the losses. Oops. I don't know how that happened. Although it's pretty close to 50, so I would say there's no effect. I doubt that's a statistically significant effect. Why didn't it happen here?
I think it was already framed as winning.
So I
I
did.
don't think it
Yeah.
really triggers a loss aversion.
Yeah, so imagine you just won a $200 prize, but now you have to make a decision where you may lose money. That's right. The reason I didn't want to ask you about only losses, because there could be a true wealth effect there. Like you don't have $500 to lose. You don't have $1,000 to lose, and therefore you have to make a certain decision. But I think that's right. I think maybe you weren't purely thinking of this as gains and losses because I gave you this 2,000 to start with. That's probably what happened, right? Or it's just not as strong, this feeling of avoiding losses when it's, life and death. Life and death is when it's really strong feeling of avoiding losses. Whereas here, you almost felt like you had house money to play with and it wasn't very strong. So that one didn't work. Forget about that one. Let's just bask in the glory of how different this one was. 83% choosing the safe option in the gains and 90% choosing the risky option in the losses. Great. You guys are good. What else do I want to do? I did want to write the function that has all of these three things. Although I won't write it, I'll just go to my slides because they're there on my slides. Where on my slides? Prospect theory. Here we go. By the way, the function that's going to incorporate all of these things, framing, reflection, and loss aversion. I think that's it. Maybe one more thing. It's called the value function with the V, value function. So I'll show you those in just a second. Computer, this computer. Okay. Right. But once again, I'm going back to the probability weighting function. It's the thing that explains this flip. And it has these two things. You can go back and look at these slides because I say exactly what I said in class. Explains a certainty effect, explains insensitivity of probability changes. Not explains, but it's consistent. And this is often one of those. Actually, I got this right from their paper. I put the original prospect theory paper on Canvas. You don't have to read it all. I'm not going to give you a reading response to the whole original long paper. But it might help to just look through it. It's nice to see the original. I don't see people talking about it. You can see exactly what the two guys who wrote it said about it. And this is taken from their paper. You can see it's kind of like what I drew there. They didn't emphasize the flatness quite as much as I did, but it's still there. And okay, Now's where we're talking about these anomalies concerning gains and losses. And this is a famous probability psychologically. Like I forget, you said you had it in some psychology class asked you this question. It's a very well-known effect in psychology that you can have this flip, whether something is framed as gain or loss. People saved versus people dying. So what do we learn? Framing matters. Framing matters because whether you start at the point, whether they're framed as gains or losses, reference points matter because whether we're starting at 0 people dying or 600 people dying seems to affect. And loss aversion occurs. We talked about all 3 of those things over there, mostly. So this experiment didn't work on you guys. Okay, sometimes it works, sometimes it doesn't work. This one didn't work on you guys. But the important finding is that people are risk averse over gains and risk seeking over losses. Would you at least agree with that? There's something about gains where you don't really feel like taking a big risk. You're just happy with some gain. You just be satisfied with it. Whereas if you're talking about losses, you do want to take that risk. Why should you take the risk in losses? Because if you get lucky, then you could completely avoid the loss altogether. And that's such a great thing for you psychologically. To avoid a loss is really nice because I hate losses. That's why I'm risky the domain of losses. Okay, so we're almost ready for the picture. The next slide is the picture of the value function, finally. There it is. Beautiful. 3 things all captured in one, thanks to Kahneman and Tversky. What are the axes of this graph? Notice it's not X, it's not money. It's not like wealth on the X-axis. In fact, I'd actually love for you to do this. If I ever ask you to draw this graph for me, and I say, please label the axis, you actually have a different label for this axis going to the left and to the right. That's not very common in math. Usually you just have an x-axis with one label and a y-axis with another label. Here, the x-axis gets labeled 2 different things depending on the direction you go. This direction, the label should be losses. This direction, the label should be gains. That's intentional. Yeah.
I mean, it's still kind of the same thing. It's just losses means negative and gains mean.
Mathematically, I agree with you, but these guys are not math, they're psychologists. And in their interpretation of it, those are different. You can put them on the same axis because and it makes sense to put them on the same axis because, right here is no change. This is a special point called the reference point. The reference point has to be this point right here in the middle where there's no gains, no losses. That's just what your status quo is. But they do think of a gain and a loss as somehow fundamentally different. Even though I know you're thinking like x equals 1 versus x equals -1. Those are just 2 different directions of x. I mean, it should be equal. And mathematically, I agree with you. But just for this class, let's say, please label this as losses and label that as gains. What about the y-axis? You don't need 2 different labels for that. That's just value. Just call it value. Notice it's not utility. Utility is what economists use as part of expected utility theory. It's covered up there. But EUT would tell us, wealth on one axis and utility on the other axis. That just doesn't work, right? It's not going to work to capture these phenomena that people have psychologically. This does. In a number of different ways, this value function captures a lot of the weird things that we saw people do that we already talked about in the first half of this course, like the status quo effect. Why is there a status quo bias? I'm sorry, bias. Status quo bias. Why is there a status quo bias? It has something to do with this point here, this reference point, is also focusing us into that, to not really want to venture too far out in the domain of gains if it's risky, and definitely not to venture out in the domain of losses. That's terrible. There's something there pushing us toward the status quo bias. It's not explicitly on this graph, but it's there. What about loss aversion? Can you see the loss aversion on this graph? Yeah. Where?
It's actually much deeper and longer than.
Yep. You can look at like this one versus this one. That's the, by definition of loss aversion. It's more painful to have a loss than it is pleasurable to have an equally sized gain. This gain and this gain look, or sorry, this gain and this loss look to be about the same size, but in terms of the effect on us, it's hugely different. That's loss aversion. So if I asked you to sort of characterize this function, it's like draw it and characterize it for me. Tell me what are the characteristics that this function should have. Okay, it has the two axes. It has a reference point where the value function has to go through the reference point because that's where nothing's happening. But it's important that it has a reference point. It has loss aversion because this is really steep and this is not as steep. It's steeper in the domain of losses than it is in the domain of gains. That's loss aversion. And I think there's one more thing, which is the reflection effect. What is the reflection effect? That has to do with the curvature of the function. Is that what you were doing with this? You were really doing this? That's perfect. The fact that this is going, that tells us this person will want to be risk seeking. Anytime you have the mathematical term for this is convex. You guys have heard this term convex? C-O-N-V-E-X. Because this function is convex, that means if ever I have a choice for getting like two different points on this curve versus just taking one point for sure, I would rather take the risk. Take the risk because it's convex. If you took high school math, sometimes this is called concave up. But in college, we don't call it concave up. We call it convex. If it's curving up like this, that means it's convex. If it's curving down, getting flatter and flatter and flatter, that's called concave. So the best way to say this mathematically is this value function is concave in the domain of gains, and it's convex in the domain of losses. And that's what characterizes the reflection effect. I think I've said it all. I think I've said the three things that are built into this graph, which characterize the psychological phenomena that are missing in expected utility theory that should be included in prospect theory. Do you guys have any questions about this value function? I say the value function. Maybe I should have said the prospect theory value function because, okay, there may be some other value functions out there that this is not. I'm not claiming this is the only value function. I mean, this is the prospect theory value function. Can I show you my slide about the properties that it should have? I've already talked about it. This is my list of the things I was saying. Because it has this one reference point, has a special point in the middle, because this point is special, everything's compared to this point. That's what explains framing effects. Framing effects could be like, wait, if I change the reference point in your mind and then something that was a loss was now a gain, etc. It also is steeper in losses than gains. That implies loss aversion, said already. It's concave in gains, convex in losses, that implies reflection effect. So really, those are the only real three things I'd like you to know about the value function, about like what has to be in there for it to be a value function. Guys, any questions? There's a few more implications I would love to show you. One thing, oh, I've already said this one. Framing something as a gain, the loss may change your risky decision. Sorry, that's not an other implication. That's one I've already talked about a lot. So ignore that one. How about this one? I haven't talked about this one yet. This one says, the farther you are from your reference point, the less you care about even further changes. And this goes in both directions. So I've already gained a lot, but I'm not particularly interested in gaining more. Why? Look at the shape. Oops, I gotta go back to the shape. I've already gained a lot, then future gains are just really flat. I'm not like that interested in those future gains. Who cares? I'd rather just stay where I am. I don't want to risk going backwards. I'm all the way up here. I'm happy just staying there. What about losses? I've already lost here. This is kind of weird. I don't know if you guys agree with this. This is saying if I've already lost a bunch, I don't even care if I lose anymore. It's like if you hit rock bottom, you got nothing left to lose. I don't care. I'm gonna go take very risky drugs and, jump off the Empire State Building and do whatever I want with my life. I'm already a rock. I mean, it's not quite that bad, that bleak. But I feel like psychologically, that's a little bit what's going on here. Where if I'm already this bad, I've hit rock bottom. Who cares? I mean, I'll bet everything. You don't have anything to bet. I don't care. Just bet it all. That's the mentality that's at least implied by this value function. You guys can say whether or not you agree with that. That's one implication. Squid Game. Yeah, those guys are. Why are they doing all this crazy stuff to try to win? It's not worth it if you die. But I guess if they're already at the bottom part of their life, they figure, might as well risk it. I got nothing left to lose. I do think that is actually kind of a good example. Okay. Another thing is about bundling. Let me just talk a little bit about bundling. What do I mean by bundling? If you could have two gains, but you experience them at two separate points of time, it's better than if you experience both gains at once. What do I mean by better? I've got to go back to the function. If I get, let's say, this size gain here, this size. If I get this size gain, I'm going to get that bump in value that makes me feel good. Now let's say some time has gone by and my reference point has adjusted. Now I'm back here again. And I get another gain that day. I get that bump again. Those two gains separately give me a higher psychological benefit. Whereas if I had those two gains together, all just combined in one, I would experience this much once and this much here. I would be somewhere like there. And you can tell that's not nearly as good as getting this value twice. Getting this value once or this value twice is way better. Get the right. Implication is, I'm just going to pull this out. It's like pulling out my head. It bothers me. Sorry. I have an untucked shirt. It was annoying. The implication is that bundling gains together actually, in the long run, decreases this person's value. What about bundling losses together? That's actually better for them, right? Somebody would rather experience two losses at once than experience two losses separated in time. That's the implication of this function, if you believe it. Do I believe it? I think I do. You know what comes to my mind? Baggage fees at airports. You get so pissed at those guys. Like, I just want to put a bag. I mean, I can't carry this bag. It's so heavy. Just let me dip it. Like, no, it'll be $30. You experience that loss of $30 right there at the airport when you have to stick your credit card in and pay for it. Whereas, if you had paid for that $30 as part of your fee when you bought the ticket in the first place, you wouldn't feel so bad about it. Why? Because that loss would be experienced as like just another $30 down here. Not a very big significant psychological effect on you to just pay another $30 if it's bundled into the whole cost of the ticket. Whereas if you've already paid for the ticket and you've got a new reference point, you show up at the airport, you're excited to go on your vacation, and you get reminded because it shows you on the screen, you have to pay $30 for your bag. That's like a big loss psychologically. Because rather than bundling it together, like the airlines should do, I think this would make sense using behavioral economics, they should do that. Unless they actually don't want you to check the bags, which I think is true. They want you to feel pissed about the baggage fee and say, okay, I'm not going to check my bag because of it. Or I'm not going to check it. I might carry it with me on the plane. They don't care if you do that. They'll fill the rest of the airplane with other stuff that they can ship. Yeah.
Are they make more money than someone's swim?
Exactly. Yeah. So I guess that's why they do it. I don't think it's that airplanes don't understand. Airlines don't understand behavioral economics. It's that they actually have different interests than making you happy. They don't care about that. But wouldn't you agree? That's an implication. This whole bundling. I'm sorry to have not that much time. I just want to make sure I get through prospect theory before tomorrow because I have a quiz tomorrow. Not tomorrow, Thursday. So I think we're doing pretty good. Can we talk about these other things? Shifting your reference point is a little funny. I mean, I know this literature and I sort of know how they talk about it, Sometimes your reference point shifts and sometimes it doesn't. Richard Thaler is an economist I admire greatly. I follow him on Twitter. He has good tweets. But when he wrote a paper about like taking prospect theory seriously in terms of your financial decisions. I'm making a financial decision. That's a huge decision under uncertainty. How risky do I want my portfolio to be? What he did was try to figure out how much time goes by before your reference point shifts. Right? Like by shifts, I mean, I shouldn't say shifts, I should say like adjust. You readjust. Like let's say you buy a bunch of cryptocurrency and it goes up in value a lot. Are you still thinking of that cryptocurrency as just purely a gain? Or is there, after some period, you think of that money as yours? And therefore, if it goes down, price of Bitcoin goes down, do you experience that as a loss? Versus the fact that you may have never really incorporated that into your status quo. And therefore, if you lose a bunch of money on Bitcoin, you don't really experience it as a loss. It's just less of a gain. That's a real question. Of course, it's a psychological question. I don't know the answer to that. How you guys feel when your Bitcoin goes down, or your Dogecoin that might go down. But Thaler tried to look at this and see like psychologically what makes sense. And for most investors, it's actually a pretty long time. It's something close to a year, actually. So if you have a bunch of gains and losses throughout the year, you don't experience all of those separately necessarily. We tend to think of a little bit longer term, at least in terms of our financial gains and losses. And something like yearly seems to be the best way to do it, at least for investors. Like for you guys, maybe you do experience the loss of Bitcoin. Whether you're Bitcoin investors, I heard the price went down for Bitcoin. So some people may be really pissed because they incorporated that money and they thought it was theirs and now it's gone. But I think that would be a little naive, thinking that, you know, just because you have it, the price is volatile, so they should have known. But okay, enough about Bitcoin. This is a quote I got from the book Predictably Irrational that says, let me go back to the picture. If you do get a big gain, let's say you become really rich, you get a lot of money, you got a really high salary, you love this, you're on top of the world, everything that you been waiting to buy, you can now buy. Eventually though, it becomes your normal. You become used to this high level of consumption and spending. You're not really as excited about all these gadgets you get to buy and use. Why? Because you adjust. And the quote was about cars, saying that like you buy a fancy car and you're happy for a while, but eventually you get used to it and you're still jealous of people who have even better cars than you. There is no best car. Whatever car you buy, you'll always be able to see and compare yourself to somebody who's got a better car. So this guy's strategy is I don't even bother with that. I just drive a simple car like a Prius. Okay. Last thing about prospect theory, and then we're pretty much done. Actually, we're not done. We'll talk about the applications. We'll talk about those on Thursday. Right now, I'm just telling you the theory. Here's the theory. Here's what it is. Thursday, we'll talk about the applications. This is the editing phase of prospect theory. What is the editing phase? I like to think of it as your brain telling itself, before I start really thinking about this problem, let me just make sure I understand what's going on here. What's really going on here? That's what the editing phase is. And I'm not gonna ask you to repeat these in any, you can write them down if you want, but these are the processes of the editing phase that are listed in the paper. If you look at the prospect theory paper, you'll see these listed. Each one of them, they give you some example, but it's a way to basically process the information of something that may be uncertain. Let me give you an example. If I told you, I'm going to flip a coin, and if it's heads, you win $10. If it's tails, you win $10. You can either have that, or you can have this other option, which is $8 for certain. What's really going on here? You have a choice between $10 and $8, right? The heads and tails is meaningless. What's the point of this? What I'm saying is, and what Kahneman and Tversky are saying, is that people aren't stupid. You can't trick people by doing this meaningless coin flip of heads and tails and saying that your outcome somehow depends on the coin flip when it actually doesn't. Because if you think about it, the theory says that I don't actually use 50%. What I use is the probability weight of the 50%. If you did that, if you think about it, you could sort of manipulate people's probabilities. Let me rephrase this. If there was no editing phase, then the theory would make all sorts of terrible predictions that say, all you have to do is flip a meaningless coin and you can get people to take outcomes that are clearly worse for them. So the editing phase is there to say, no, people aren't that stupid. What they do is if they have probabilities that are the same, they combine them. They can encode something based on what it actually is, what's the true effect on their life, not some weird way that you're manipulating it. You can segregate gains and losses in a way. You can segregate probabilities, and combination is actually pretty interesting. It's about multiple probabilities. Like if you have like a coin flip and then another coin flip and then another coin flip, you don't necessarily treat all of those differently. You can somehow combine to at least in your mind, think about what's the actual probability of this whole thing happening. And sort of cancellation, simplification. You can read about these things if you want. In terms of this class, I'm not going to ask you specifically about any of these things. Rather, I would just want you to know this concept of the editing phase of prospect theory, which says people don't make stupid mistakes because they get tricked and not really understanding what's going on. Does that make sense? Okay. I think that's all I wanted to say today. If you guys have any questions about like what's going to be on the quiz or what this prospect theory thing is, we should feel free to talk about that now. But I do want to have the quiz at the beginning of class on Thursday, if that's okay. And it'll just be on this prospect theory and the previous module, which was consumer choice anomalies. Thanks, guys. I think it was a different class. Thanks. Different class where somebody asked the